In this video, we're going to talk about solving equations for a variable and explaining the steps in that process using the properties of real numbers. If you have a list of the properties of real numbers, it would be helpful to keep that on hand. So to begin, what does it mean to solve for x? You may have heard the phrase, get x by itself. And that's an informal way to say it, but it is helpful in remembering exactly what that solution is supposed to look like. We want to get to the point where we have x equals and then some number. So another way of saying this would be find the value or the number that x equals. Find the value of x. And a third way of saying this would be find the identity of x. And for the purposes of this video, we want to focus on this third one, find the identity, because you do have an identity property, and that does explain why we're doing the steps in this process. Alright, so first of all, we have the identity property of addition. Identity of addition. I'm going to start abbreviating now, so identity of A, identity of addition. And this property tells you that when you add 0 to any real number, the identity of that real number is preserved. It's not changed at all. And that works for any real number. And then second, you have the identity of multiplication. And this one tells you that if you multiply any real number by 1, that preserves the identity of that real number. It's unchanged by multiplying by 1. Alright, so you can see an example of an expression here at the top, 2x plus 6, and we don't know the identity of x in this case, and the reason is that we have numbers here that are not 0 and 1. So we don't know what x is because it's not multiplied by 1 and it doesn't have a 0 added to it. It's multiplied by 2 and it has 6 added to it. So those things are kind of obscuring the value of x. So if I knew how to transform this equation, or this expression, to the point where it was a 1x plus a 0, then I would know the value or the identity of x. So you might want to keep that in mind as kind of the goal as we go through some examples of equations. We're trying to get all of them to the point where we have a 1x plus a 0 equal to some number, because we know from these identity properties that 1x is just x, and then x plus 0 is just x. And then we would know what the value of x is. So we need two more properties to work with equations. At this point you only have properties for real numbers. So we have two of these, one for each operation. Right? We have an addition and a multiplication property. So your multiplication property of equality is the one that tells you when you have a true equation, something like 5 equals 5, that you can multiply both sides of the equation by the same thing and the equation is still equal. So in this case I multiplied both sides by 2 and I can see and check that 10 still equals 10. And I could have chosen to multiply by anything. I could have done 1/2. And then I know that that's still a true equation. Alright, so easy to check when it's real numbers, but this will come in handy when it's time to solve and find the identity or the value of x. Your addition property is the property of equality that lets you add anything to both sides of the equation. So if I know that 5 equals 5, then I can add 1 to both sides and the new equation will still be true. Okay, so let's do an example. Here we have x minus 2 equals 8, and if x just stands for some real number, you might be able to see from inspecting this that the value of x has to be a 10. That's the only real number where if you subtract 2, you get an answer of 8. So let's go through the steps in how to solve and find that value of 10 for x. Alright, So let's keep our goal off to the side here. We want 1x plus 0 equal to some number, because then we would know what x equals. Alright, so first of all, notice that you don't have anything multiplied by x, so the first part of our goal has already been accomplished. We have just a 1 times an x. Now the second part is the part that we need to work with. We have a minus 2, and what we really want is a 0. So if you think back to your properties, you have a property that tells you how to get minus 2 equal to a 0. And the answer is the inverse of negative 2. If I was to add 2 to this, then I would return that negative 2, or I would turn it into the identity into 0. So if I add 2 to both sides of the equation, then on the left, this is going to help me have 1x plus 0, and on the right, 8 plus 2 would be 10. Alright, so we actually used two properties here. First of all, we used the, let me clear this out. At this step, we used the addition property of equality to justify why we could add 2 to both sides of the equation. And then I had a second property that explains why negative 2 plus 2 equals 0, and that is the inverse property of addition. Right. Now we had one other change here. We had 8 plus 2 equals 10, and we don't need a property to justify that because that's just addition. That's the definition of addition, but you don't need to write that. Alright, so our goal has been accomplished. We know that 1x plus 0 is the same thing as x, and now we know the value of 10. Alright, and that's just as we suspected. We could see that 10 minus 2 equals 8. Alright, let's look at one using a different property. This time we have 4x, and the issue is that there's something multiplied by the x other than a 1. So we would like that 4 to be a 1, and if you think carefully about how you could turn the 4 into a 1, we again have a property for this. We have an inverse property that tells you if you multiply by the inverse, then that 4 will become a 1. Right, so what I will do is multiply each side of the equation by 1/4 with that goal in mind. Alright, and I need a property to justify why I'm able to do this, and that property is the multiplication property of equality. Right, that's the one that says we can multiply both sides by 1/4. Alright, now you may have also learned to divide both sides of the equation by 4. And that's also correct because remember that dividing by 4 is the same thing as multiplying by 1/4. Alright, so it's this multiplication property that also justifies why we can divide. Okay, so now on the left we have 1/4 times 4, and that's a 1. And we know that by the inverse property of multiplication. Right, inverse property of multiplication. Okay, and then finally, I know that 1x is the same thing as x by the identity property. And now I know what the identity or the value of x is. 1/4 times 15 is 15 over 4, 15/4. Okay, so we've solved for x, we've found its value, and we've used 3 different properties to explain each step. Alright, here's another one. We have one more property that you can use, and that is the distributive property. Alright, Alright, so if you remember this one, we've got a 5 multiplied by a sum, x plus 6, and your distributive property tells you that you can multiply that 5 by both things inside. So this would give you 5x plus 30 equals 20. Alright, and then with my goal in mind, what I'd like to do is get rid of this 30, make that a 0, and make this 5 into a 1. Alright, so to start, if I subtract 30 from both sides, that will give me a 0 over here. And we need a property to justify that. So we don't have a subtraction property of equality, and the reason is that we don't really need it if you just remember that subtracting 30 is the same thing as adding a negative 30. So we can still use the addition property of equality to justify this step. Alright, and now the goal has been accomplished. I have 30 plus negative 30 is a 0, and that's the inverse property. And on the right, 20 minus 30 is negative 10. Now I know 5x plus 0 is the same thing as 5x, and that's the identity property of addition. Alright, and I'm almost there, and then I need this 5 to be a 1, and if I multiply by 1/5 or divide by 5, I'll accomplish that goal. Alright, so that is the multiplication property that allows us to multiply both sides of the equation by 1/5. And then I have 1x on the left, and on the right, 1/5 times negative 10 is negative 2. Okay, I could justify that. 1/5 times 5 is 1 because of the inverse property. And then finally 1x equals x, and I know that by the identity property. Okay, so you can see what's interesting about this is that there are actually many, many steps to what you may have thought was a fairly simple or at least short equation to solve. So this is all of the work that actually is going on behind the scenes with these properties to explain how we find the value of x, how we find that x is negative 2. Alright, so let's do a longer one, and I've actually written out the steps for you. So let's just go through and see if we can figure out the property that justifies the change from step to step. Alright, so when you're trying to do this, what we'll do is we'll look at each step, so this is step number 1, and then we'll look at step number 2, and we're just looking to see what's been changed between these two steps and see if we can come up with a property that explains why that change is okay to make, how we know that the equation is still true, that it's still the same problem. Alright, so as you look at step 1 and step 2, the only real change that's been made is that the 5y and the 2 have been switched. Alright, so if you want, go through this and pause the video and look at your list of properties and see if you can come up with a property that justifies each of these steps. So we won't have one for number 1 because this is just the original problem. This is the given problem. But see if you can think of properties that justify each of the other steps here. Okay, so you may have come up with the commutative property for step 2. And I'm going to start abbreviating again, commutative property of addition. And that's the one that tells you you can reverse the order of the two numbers that are being added together. Alright, next, from step 2 to step 3, it looks like everything has stayed the same except the placement of the parentheses. So that's the associative property, and in this case of addition. Alright, From step 3 to step 4, the change that's been made is, looks like the y has been moved outside the parentheses, and this is the distributive property. Okay, it's just going backwards here. We're kind of undistributing that y from the 5 and the 2. Alright, step 5. This one actually would not have a property either. You can say that this is the definition of addition, or you can kind of just leave this one blank. 5 plus 2 is 7 is the only change that's been made. Alright, here are the next steps in solving this equation. And maybe pause again and see if you can come up with properties that justify. Okay, so if you've had a chance to look through your properties, right, from the previous slide we had 2 plus 7y equals 12, so we're picking up there again, and that is step 5. Right, so from step 5 to step 6, it looks like the change that's been made is this negative 2 that's been applied to each side, and that is the addition property of equality. Alright, from step 6 to step 7, two changes, we have negative 2 plus 12 is now a 10, and that's not something that can be justified with a property, so we're going to ignore that and move on to this other one. And we need a property that justifies why negative 2 plus 2 becomes a 0. So that's your inverse property of addition. So notice we're not really justifying the just plain addition problems, but there's something special about these ones that have a number and its inverse. So just look for either sums adding up to 0 or things being multiplied to equal 1. And anytime you see a 1 or a 0, that might be a clue that you need a property. Alright, so here we go again. From 7 to 8, the change that's been made is that we had a 0 plus a 7y, and now we just have a 7y. So we're asking why does 0 plus 7y equal 7y? And that's your identity of addition. From step 8 to step 9, the change is this 1/7 being multiplied to both sides. So that's your multiplication property of equality. And then from step 9 to step 10, two changes on the right. This is just a multiplication problem, so we'll ignore that. But on the left, we have 1/7 times 7 equals 1, and that's the inverse property. Inverse property, and this time for multiplication. And then finally from step 10 to step 11, the change is that 1y is y, and that's the identity of multiplication. And finally we're done. We have y equals 10/7, so our goal has been accomplished. We have 1y plus 0, or just y, and we know what y, or what the value of y is. Alright, just a quick reminder, if you go back to your original equation, you can check that this is the value of y by substituting it in for the y every place you see it in the equation. Right, so replace y with its value with 10/7 and see if the equation is true. Okay, and then finally one more example. We did look at this problem using the distributive property before, but there is a second way that you can solve this. Alright, so let's try this again. Alright, so pause the video and see if you can identify a property for each step other than step 1. Okay, so for step 1 to step 2, the change that's been made is this 1/5 on both sides. That's the multiplication property of equality. From step 2 to step 3, two changes. On the right, we just have a multiplication problem, and that's not what we're trying to justify. But on the left, 1/5 times 5 equals 1, that's the inverse property of multiplication. From step 3 to step 4, the change is that we had a 1 and now we don't. So we're saying 1 times x plus 6 is the same thing as x plus 6. So that's the identity of multiplication. From step 4 to step 5, we've subtracted an x on both sides. So that is, if you think of that as adding a -6, that's really your addition property of equality. And then in step 6, the change is that 6 minus 6 equals 0, and that's the identity of addition. Oh, I'm sorry, that's the inverse of addition. Inverse. Getting ahead of myself here. And from 6 to 7, this is the identity of addition. Because what we're saying is that x plus 0 is the same thing as x.